we will discuss about this tutorial, and also we will enter the chapter 7, the last chapter, a little bit from the last chapter, because next Monday, okay, we're supposed to have class, another class, right, next Monday, but on next Monday I couldn't attend the class because I have Viva PhD Viva student PhD Viva evaluation, so I couldn't attend this class. So we will cover also for the next week. Okay, so next week takkan ada class, but instead of that, I will put some of the bank of questions maybe that I have for your practice for your final. Okay, right? Okay, so for the tutorial, please look the slide that I believe I already given to you at the e-learning. Mana? Oh, my pen tab. Mana my pen tab? Oh yeah. It's difficult for me to write. Have you tried the questions? Or is it too difficult? You can't even try the questions. Siapa yang baru join? Okay, so I hope you tried, tak banyak pun, I think you have gone through the questions and you have tried a little bit so that you are not too blur to attend this tutorial, okay? So kalau I explain pun you don't tak blur sangat, right? So let's look the first questions, okay, tutorial of OPAMP. Alright, so the first questions, alright, figure Q4A, so we have two figure here, which is, this question is from from the previous, from the previous test, and also from, usually on the previous final test, yeah. Okay, so there's two figure here, figure Q4A and figure Q4B are the circuit of a Schmidt trigger. Okay, so just already mentioned the circuit is a Schmidt trigger circuit, and it's a transfer characteristic respectively. So these are the transfer characteristic given to you, and based on this figure, you need to determine the V reference and also R1, the value of resistor 1 here, and also the value of V reference here. So macam the other way around with the formula that given to you, right? So and then another question is sketch 2 cycle, okay, of output voltage, the output voltage. So VO, if the input voltage is VI, so the input voltage is given to you, V input is equals to 10 sine omega t volts, yeah? So it means that the input voltage, the maximum is 10. So it's mentioned to you that it's 10, the amplitude is 10, yeah? So the amplitude is 10, so the input will be, yeah. Okay, the amplitude value is 10 here, and down here is also minus 10, yeah. Alright, okay, so let's go look. Okay, another information what you can have from this figure is, you know, the UTP and LTP value, right? So these are the VLTP value, all right, and this is the VUTP value. So that are the information that is given to you, and also the positive of V saturation, okay, V output saturation, yeah, positive V output saturation and minus V output saturation. So all of this information you can get from this the transfer characteristic graph, yeah, and you have the input. This is the input wave, yeah. Okay, so let's first of all look how to determine the V reference and also R1. Okay, so let's look one by one, yeah. Figure Q.4, Q.4A and Q.R. Okay, so these are the questions again. So these are the figure. Okay, so as I mentioned to you, from this transfer characteristic, you have two value. No. What's this? Okay, you have VUTP here, all right, and you have VLTP here. Yeah, I have to accept this. Yeah. Okay, all right. So VLUTP, upper trigger point and lower trigger point. Yeah, it's from this information here. So we have we know this equation. Yeah, this formula from previous class. Yeah, if V plus, okay, if V input is more than VUTP, it will be the V output will be minus VO saturation, right? So from here, the formula for VUTP is here, okay, where V reference R2, okay, V reference you didn't know, you need to find, okay, V reference the one that you need to find, but R2 value is given to you. V output, the value of V output, you need to take the value of, sorry, this is for if V input is bigger than VUTP, so the value of V output will be positive VO saturation. Sorry, so because it begins from here, right? So it will be, dekat sini will be the value of VO saturation, the positive value here, all right? And then R1, the one that you need to find. So the one that you need to find, just leave that, like that, okay? And then the integer here, yeah. And then R1, okay, so, apa? Just so nama malah apa tu? Apa namanya? Just macam tu je lah, ya. R1, and then R2 is 1k ohm, and then okay, it's just like this, okay, and equals to 7.4, okay, because it will equal with the value of VUTP, right? So 7.4. So and then this is going to be your first equation. Okay, you rearrange this number, and this is going to be your first equation, right? And then since that the unknown integer is 2, so you need 2 equations to solve this 2 unknown values of integer, right? So you only have 1 equation here, so you need another equation. So another equation you can take from the VLTP, which is from here. So VLTP, the value of V reference, the one that you need to find, and then R2 is given to you. For this value, for this VO value, you need to take the value of minus 9. Okay, minus VO saturation here, which is minus 9. And then R1 you need to find, and then you have, it will be equal with the VLTP value, which is minus 3.4, and then rearrange this equation, you will get another equation, okay, equation number 2. So this one, since that you have 2 equations here, okay, both equation contains the same unknown which is R1, okay, which is R1. So if you make the V reference as the main, right, but if you make the R1 as main, so V reference is going to be inside here, yeah? That's basic maths, okay, I don't have to go there. So since that the both equation have the same value of V reference, so you can substitute, 1 into 2, right? So it will be like this, and you can rearrange the equation, and you can find the final of R1 value is 1.5 1.5 kilo ohm or 1,500 ohm. Okay, 1,500 ohm. 1,500 ohm or 1.5 kilo ohm. All right. So once you get the value of R1, okay, you already have 1 box for here. Yeah? We already have calculated 1 unknown from here. So you can just replace the value of R1 into the equation here. Okay, into one of the equation. You can put it in either in UTP or LTP. Okay, choose which equation that you prefer, and you will get the value of V reference 5 volts. All right, 5 volts. So this is gonna be your answer for V reference here. Okay, I think this question is very easy. This is very straightforward. Okay, any problem from here? I hope no. Any problem? Okay. Up until here?
Doctor.
Yeah.
From the figure Q.4b, what does the arrow indicates?
Arrow indicates, okay, this is the hysteresis arrow. Hysteresis arrow means that I think from the previous class I've taught to you that it will start from here. It will start from the from the positive value here, and this part it's just like a loop like that. Yeah, this part is represent for the VUTP. It means that the voltage, the voltage can't go further more than 9 volts. This is the saturation value, and it will quickly drop when the input voltage is at 7.4. So that's why this is what we call here VUTP, which is the upper trigger point for the for this Schmidt trigger circuit. Okay, it means that it can't go for the input value. Yeah, it can't go more than 7.4. 7.4 is the upper limit for this input value. All right, because more than 7.4, it will be the minus the output. Yeah, the output value will be quickly dropped to minus. Yeah, you can see there is a very very exact difference when 7.4 volts, if the input value at 7.4 volts and 7.3 volts, okay, which is 7.3, the value of V output will be still plus 9, which is still in the positive side. Yeah, but once at 7.4 volts, it will be quickly dropped to minus 9. Alright, so this is what we call hysteresis. Hysteresis means that dia macam it's just like a loop here. Okay, and after that, so if it means that if the input value is further than 7.4, it will go this way. It will go this way. It will go this way, which is it will maintain minus 9 volts. Yeah, but if the input value is changed, okay, if change back to 7.3, so it will be here again. All right, so now that is for the upper trigger, okay, upper trigger point. For this point, from this point, yeah, from this point, these are the lower trigger point. So it means that from here, yeah, it will start with when the V input is it will start when the V input is lower than V plus. Means that when the V input is at the minus side, okay, at the minus side here, okay, at the minus value here, yeah. So it will be around minus 9, which is minus VO saturation value. And then once the input value, okay, the input value is 3.4, what will gonna happen? The output volume, the output value will quickly go to the positive side of the saturation voltage value, which is plus 9. So if you look here, hysteresis, dia akan bentuk, it will make a rectangle shape like this. Okay, rectangle shape like this, right? So this is when actually there's lots of hysteresis. Yeah, so this is for the Schmidt trigger hysteresis. For other experiment, we have other hysteresis, and all the hysteresis shape usually will be like this. Yeah, this is the positive side, and this will be the and this will be the this will be the negative side. Okay, this is going to be the negative side. So this is the hysteresis transfer characteristic for Schmidt trigger. But what you need to know, what the information, the most important thing, yeah, when there is a hysteresis here is given to you. Usually hysteresis graph is given to you. the most important thing, okay, once for this graph, you need to know how to read this graph. Yeah. So what information that you can get from this graph? Okay, for example, in this hysteresis shape, you can know the positive and minus value of VO saturation, which is positive 9 and minus 9. And also from this graph, you know that the value of V UTP and the value of V LTP. So you need to know how to read this graph. That is the important thing for this hysteresis graph from this hysteresis graph. Okay. Right. So this hysteresis, yeah, only have for the Schmidt trigger for non-linear. Okay, we don't have hysteresis for linear OP-amp. Right. We only have the hysteresis for Schmidt trigger non-linear. All right. Okay. Yeah? Until there is okay. All right. So done with these questions. Let's proceed to the how to sketch the 2 cycles of the output voltage. Kalau tak sempat, later on I will give this slide inside your e-learning later on, yeah. Okay, next, let's sketch 2 cycles of the output voltage VO if the input voltage, okay, is given to you, yeah. The V input voltage to you is 10 sine omega t. So sine, it means since that the sine, so the shape is going to be the sine sinusoidal graph, right? There will be no other shapes. There will be no other shape. Okay, so the amplitude is 10. So you can see here, this is the maximum amplitude and this is the minimum amplitude, minimum point and upper point, yeah, based on from this amplitude. Okay, so next, you know, again from this hysteresis value, okay, from this hysteresis transfer graph, you know the value of VO positive minus VO saturation. So what does that mean? It means that it will not your output value will not go further this 9, more than positive 9 and more than minus 9. All right. So that is another hint that you can get from this graph. Yeah, from this graph. Okay. So your answer shouldn't be more than positive 9. Shouldn't be less than minus 9. Okay, so we will be between this one. Okay, right. So next, what you can another information is your UTP and LTP. So once you get your UTP and LTP, make a dotted line here for UTP, which is this will represent UTP, and another dotted line where it will represent the LTP. Okay. Next, what you need to do, you need to compare this input, okay, this input graph with this UTP and this LTP. For example, here, yeah, at this moment, yeah, at this time, at this interval, you can see that the UTP is higher than this UTP point, yeah, is higher than the input. Okay, at this interval. At this interval, V input is lesser than V UTP. So what will be? Your output value will be, when V input is lesser than V UTP, your output value will be positive 9 volts. Yeah, positive 9 volts. And also you need to look where is the input. Okay, kalau macam ni, the input is at the inverting, right? At the inverting point. So it will be positive 9 volt. If the input is at the non-inverting, which is at the positive, it will be the other way around. Okay, so you need to look if you want to draw the output, yeah, you need to compare first the value of the input with the UTP, okay, and also make sure where is the locate where is the input signal come from. Okay, if the input signal is at the minus, so it will be, if V input lesser than V UTP, the output value will be positive 9. So at this interval, it will be positive 9. Okay, so when at this interval, at this interval, yeah, at this interval, you can see it will goes to at this interval, since that this is still on the positive side, yeah, positive side of the input value. So it means that at this interval, I change pen, I think it's going to be much easier for you to differentiate. Green, okay. So at this interval, yeah, at this interval, this is when the V input is more than V UTP, because it is higher than V UTP, right? So when V input is more than V UTP, the V output will be equals to minus VO saturation. So it will be placed at here, at this point, yeah? So this condition will fix well when the input signal is that at the inverting input signal, all right? And then, so done with the positive, oh, still not done, wait, yeah? Still not done at this part. Okay, at this part. So at this part, the V, same with this part again, yeah? Where is the V UTP? Okay, V UTP is lesser than, V UTP is bigger than the V input. So actually at this part, it's supposed to be kat sini. This is computer punya, sorry, dia macam salah sikit. So at this part, patutnya it's supposed to be like this, and at this part, yeah, it will be like this. Okay, it will be like this, yeah. Only at this part, okay, because at this part nanti dia dah masuk for the negative cycle, alright. So at this part akan jadi positive 2, alright. And then next, have to be very careful, yeah. Yang ni dah tersalah dah. This is because pakai komputer tak perasan dah. So repair, this will be at this part, and then from this part, when at the 0, okay, look here, which is dekat sini, actually when the V input is bigger than VLTP. So when V input is bigger than VLTP, V output will be positive VO saturation. Okay, so dekat sini pun akan jadi still positive, ya, still positive, and then susah sikit nak tengok dekat sini. And then dekat sini, wait. Serious. Cuba tengok balik graf ni betul-betul. Betul ke salah? Wait, I confirm it first. So dekat sini, when here at this point, so the input, betul. So at this point, the betul lah, it will be sama macam sini, which is it will be slightly maximum at this point, yeah, slightly, which is at this point dia akan jadi positive, yeah, positive at this point. But then dekat sini dia terus naik dekat sini. So dekat sini you just have to ignore. Okay, sekejap. So at this point, dekat sini, at this point dah jadi positif, and then dekat sini, since the ini dia dah sama, ya, it's same with this one, so namanya positif, and then at this point, so straight away look at this point, which is at this point where the V input is bigger, is lesser, which is at the negative side, kan? It will be lesser than VLTP. Okay, V input is lesser than VLTP. So when the input signal is at the inverting, okay, so it will be V input is lesser than VLTP. So it will be positive, yeah? It will be positive VO saturation. So that's why it's going to continue until here, up until here. Okay, up until here, sampai sini. So at this point, this is where the V input is bigger than the VLTP. So from this point, okay, from this point, it will be minus, yeah. Dekat sini it will be minus. So the output answer here, you just need to shift a little bit to this side. Okay, dia dah terlari sikit. You just need to shift a little bit to the left hand side, yeah. So this one going to be minus, and then back to the positive cycle here. Okay, positive cycle here. So positive cycle when the again, it will repeat this one, yeah. When the V input is lesser, when the V input is bigger than VUTP, so it will be minus VO saturation. So we're going to be dropped here. Okay, will be dropped here. Okay, so that's how you want to draw. You want to draw your output graph, yeah. So during test, during your final nanti, there's questions same like this. Okay, akan ada questions for you to draw this cycle. So please pay attention for this, yeah. And then please make sure if the input signal is given to you two cycle. For example, this is first cycle kan. This is the first cycle and this is the second cycle. So for your output graph also, please draw for both two cycles. Jangan draw only for one cycle only. Okay, if the input signal is given to you only one cycle, then your output signal, you need to draw one cycle. But if the input signal is given to you two cycle, so the output waveform also you need to draw two cycle. Okay, so please be careful with the how many input signal, how many cycle from the input signal is given to you. Okay, and please based on that. Okay, jangan buat sendiri punya. Okay, cycle. Okay. But sometimes it also didn't given to you. Sometimes the input signal is not given to you. I mean, it's only mentioned 10 sine omega t macam ni sahaja. Okay, it only mentioned to you 10 sine omega t. So how many cycle you want to do? Please do at least 2 cycle. Okay, please do at least 2 cycle. Okay, if they mention specifically how many cycle, then okay. But if they didn't mention how many cycle you need to do, please at least do 2 cycles, yeah. 2 cycles, then but usually draw 2 cycle. All right, 2 cycles of the S. Okay, so be careful with this cycle, how to draw with this output waveform, yeah. All right. Okay, later on nanti I will betulkan sikit dekat sini bila I masuk dalam e-learning nanti. Okay, so this graph need to betulkan. Okay, until now, until any questions? Betulkan output graph. Alright, so if there is no proceed, yeah. To proceed to exercise 2. Okay, exercise 2 ni dia complicated sikit. Alright, so for the exercise 2, let's look. Okay, figure Q5A shows an OP amp being used as comparator. So this is the comparator circuit, yeah. The resistance of the thermistor, which is when the RT. So thermistor resistor, okay, they have a different value of ohm depending on the value of temperature. So that's why we call it as thermistor, and there is a T sign here. Okay, there's a subscript T here because it refers that the resistor value is can be changed, yeah, when the temperature is changed, yeah, where at 25 degree the value of the resistor is 50 kilo ohm, and when the temperature is at 100 degree the value of resistor is 5 kilo ohm. So the output voltage VO saturates at 5 volts for these conditions. Okay, it saturates at positive 5 volts and positive 1 volts at this condition. Okay, why I know like this? Because they said respectively. Okay, I think this is based on this language. Yeah, so when they said respectively, so it means that this value will refer to the first condition and this value will refer to this condition. Okay, so be careful as well. Yeah, jangan terbalikkan dia and then jangan pening pula which one is which one. Alright, and then determine the output voltage V output at T25 degrees and at T100 degrees. So you have to determine the output at this both conditions, yeah. And the marks is very high, 8 marks, yeah. And another question is the LED has a maximum forward voltage of 2 volts. Okay, so this is the LED sign, alright. And this is when the LED like this, yeah. Maksudnya design like this, it means that it is light up. This is the sign of LED. So LED dengan diode, how to differentiate means that dia ada light up macam ni. Okay, so this is LED. Yeah. Kalau diode, if diode, they have no this sign. Okay, if diode, it just straight away like this, right? So the LED has a maximum forward voltage of 2 volts, positive 2 volts. Calculate the series resistance. Okay, the value of this series resistance to limit the current through the LED to 15 milliamps. So what is the value of this resistance in order to limit the currents, to make sure that the current flow here is 15 milliamps. Okay, so let's solve one by one. Okay, so these are the symbol for the thermistor. Yeah. Okay, so at T equals to 25, which is at the first condition, yeah, when the temperature is at 25, determine the voltage at P. Okay, so you need to determine the voltage at point P. So this is the point P, and output voltage VO. Okay, so at 25 degrees, okay, at 25, you need to determine the voltage at point P. So first of all, okay, voltage at point P at this point, yeah, same with the value of voltage at this point, right? The potential value of volts at this point, right? So when T is at 25 degrees, the value of resistor is 50 kilo ohm, right? All right, 50 kilo ohm. All right. So first of all, what you need to do is V is equals to IR, right? So this is from the Ohm's law. Okay, so you need to know what is the flow of currents that flow here first, right? So first of all, so ignore this part. Okay, ignore this part. Okay, only focus on this part only. So we assume that all the voltage here, okay, since that this voltage is parallelly connected, yeah, this voltage is divided into two. So this all voltage is 6 volts and ni pun 6 volts, yeah, the potential. Okay, so so just ignore this part since that this is the the value of voltage here is 6 volt, yeah, because this is the parallel. Okay, and then what you need to do is you need to know what is the value of currents flow here. So the value of current flow here by ignoring this, yeah, by ignoring this, so it will be the value of currents, yeah, will be 6 over, since that this point there is no resistor. Okay, this point actually is connected to this inverting kind of the op amp. So we know that the op amp, the value of the input impedance is too high, okay, which is near to infinity. So there's no current will flow here. So it means that only the currents will only flow here, right? The currents will only flow here. So what you need to do is you need to find the value of current at this point. Okay, the value of current at this point. Okay, so don't ignore the total value of please ignore the total value of currents. Okay, you need to just find the value of current at this point. So the value of current at this point is 6 over 10 plus the value of thermistor at 25 degree, which is 50 kilo ohm, right? So 10 ohm plus 50 kilo ohm. Oh, sorry, 10 kilo ohm. Yeah, 10 kilo ohm. All right, and then you need to know, so that is the value of currents, yeah, the value of currents that flow inside here. Once you know the value of currents, you can straight away find the potential value at point P, which is also the same potential value at point at this point, yeah. So P is equals to 6 over 10 kilo ohm plus 50 kilo ohm, okay, which is, this is the value of I, and the value of R, which is at 50 kilo ohms, yeah, 50 kilo ohm. So you will get the value of voltage at point P when the temperature is at 25 degrees will be at 5 volts. Okay, so this one is very simple. You can see that the marks is only 1 marks. Okay, ini jangan salah ini because this is very simple. Alright, and then you need to also look at voltage. Once you know the value of voltage at point P, you need to find another one is value of voltage at point Q. So now, Allah, dah terpadam pula. So you need to find the value of voltage at point Q. Okay, at point Q, Q is at this point. All right, so Q at this point. So there is another same. At this point, we assume that there is no currents flow here because the input impedance is too high. So the currents will only flow at this point. Yeah. Okay, so same sama je macam yang tadi, same with just now. Oh, this one lupa nak times 6. So 2.2 is the value of resistor at this point. Okay, and then the value of currents. Okay, the value of current at this point, yeah, the value of current is 6 divided with 1.8 kilo ohm plus 2.2 kilo ohm. Okay, so this is going to be the value of currents. Okay, and then ni ada 6 ya. At here, please insert 6 ya. 2.2 kilo ohm times 6 over 2.2 kilo ohm plus 1.8, which is come from here. So you will get the value of voltage at point Q when the condition temperature is 25 degree is 3.3 volts. Yeah. So you can see here the marks is also 1 mark because this is too simple. Okay. So here you need to compare voltage P and Q. Okay, voltage P and Q, which one is the biggest one? Okay, so here they said that when you calculate this value, okay, for you to determine the output voltage, you can see that the VP, okay, the value at the non-inverting is bigger than the value at compared to the value at the inverting point. So VP is bigger than VQ, so the output voltage will be positive 5. Okay, it will be positive 5. Yeah. So because of the input signal from here is bigger compared to here. Right. So done with the condition when the temperature is 25 degrees. So proceed with the temperature for the 100 degree. So when the temperature at 100 degree, same again, you need to determine the voltage at point P and point Q, yeah, P and Q. So same just now, what you need to do is you just need to change the value of resistor, okay, at the thermistor, yeah. So yang ni pun supposed to times 6, yeah. So you can see at this point, okay, at this point, the value of VP, okay, the value of VP is lesser than the value of VQ. Okay, so the value of VP is lesser than VQ, which means that at the inverting, inverting point is larger compared to the non-inverting. Okay, so your output voltage will be, okay, your output voltage will be positive. Sorry, kenapa positive 1? Sorry, this is not 1 ya. Positive 3.3. 3.3, sorry, ini salah sikit. Okay, positive 3.3 volts. Okay, you will take this value, yeah. Okay, so that's how you want to determine, yeah, the value of this voltage, because if you look here, okay, the input signal, yeah, input signal can come from both, yeah, can come from P also and can come from Q. So to determine the output voltage, you need to look at which voltage is bigger. Okay, which voltage is bigger, and you will take that value as the output voltage. All right, so that's how for you to calculate the output voltage. Okay, so each of them will get 4 marks. We're gonna have 8 marks altogether. Yeah, so let's proceed to the second questions. Okay, kalau ada soalan, just if you have any questions, just interrupt me. Yeah, the LED has a maximum forward voltage of 2 volts. Okay, this LED. Okay, so more than 2 volts, this LED will break, yeah. Calculate the series resistance for this Rx. So you need to calculate what is the sufficient value of Rx to make sure that the current flow here is at 15 milliamps, right? So the maximum voltage, okay, maximum voltage of this this comparator is 5 volts. Yeah, based on these two, the maximum voltage is 5 volts. Yeah, 5 volts. So 5 volts. Okay, 5 volts minus with 2 volts. Yeah, because the maximum value of this, so it means that the maximum value that come out here is 5. Yeah, so 5 volts minus with the value of this LED, which is 2 volts. Yeah. So it will be over, since that you want to measure the I, so we divide with the, you need to measure the R. So you know the value of I, which is 15 milliamps. So 5 minus 2, just divide with 15 milli, you will get the answer 200 ohm. Okay. So once you write this one, you will get 1 mark. When you write this one, you will get 1 mark too. So for these questions, yeah, so you can see if you didn't write this this information, you will lose 1 mark. Okay, if you straight away write this equation, you will lose 1 mark. So that's why, yeah, when you want to answer, just write any information that's given to you. Just write, okay, at the solution. Okay, mana tahu? Okay, because we don't know which information will give you marks. Okay, for this, yeah, for this question, this information will give you marks, which is 2 marks actually, quite big. Yeah, and this information will give you 2 marks as well, which is quite big as well. So don't forget to write this information, okay, because this information will carry marks. If you straight away write the OV output is positive 5, so the examiner, okay, the examiner will ask, why did you know that the output voltage is positive 5? So you need to clarify this. So if you want to clarify this, you said that VP is bigger than VQ, so that's why the V output is positive 5. So same as this for these questions, yeah. So when VP is lesser than VQ, so the output voltage is positive 3.3 volts. Okay. So be careful not to forget to write all this information, yeah, because this information is very useful to you and also will carry marks also. All right. So I think up until here, comparator also okay, yeah, okay ke? Any questions up until now? We try to finish at 9:15 macam tu, so that we can proceed with chapter 7 next after this. Okay, so let's look at exercise 3. Okay, so exercise 3, this is a bit complicated because yang ni dah ada Zener diode. Okay, if you look here, there is a combination of with Zener diode. So this is the Schmidt trigger circuit. Okay, assume the output will saturate. Yeah, the output here will saturate at positive minus 15 volts. Yeah, positive minus 15 volts. Given the VZ for the V Zener diode is 5.2. Okay, and the forward voltage for the diodes is 0.7. Okay, so this is the information for this Zener diode, yeah. And the V reverse, which is minus 3 volts, yeah. V reverse for this Zener diode is minus 3 volts. And V2 here, the amplitude of the input is 7, and the waveform is in a sine waveform. Alright, so determine the threshold voltage of the VUTP and VLTP. So I think this one is very straightforward questions. So easily you can get 6 marks. Okay, so here, yeah. For the Schmidt trigger circuit, so you need to know here, so the value, this one is 7, yeah. 7 sine omega t, yeah. So here, first of all, when VUTP, what are the formula? Okay, VUTP is equals to V reference. Okay, V reference times with R2. Okay, this one you have to memorize. Yeah, R1 plus R2. Okay, and then plus VO saturation, where the VO saturation will be positive value. Yeah, if this signal is at the non-inverting. Okay, so this is going to be positive value, yeah, positive VSAT. And then R1 over R1 plus R2. So these are the formula for VUTP. For VLTP, same, but the V saturation will be REF R2 over R1 plus R2 positive. The VO saturation will be minus V output saturation, yeah. So that's why they're going to be minus here. R1 over R1 plus R2. Okay. So this is when, be careful, yeah. This is when the input signal is at the inverting. Kalau at the non-inverting, so this will be the other way around, yeah. This is going to be, one of them will going to be, this will be minus, then this will going to be plus, yeah. Okay. All right. So next, you need to know what is the output value first. Okay, you need to know what is the output value first. All right. So when the V output is positive, yeah, V output saturation, which is for the UTP. Okay, UTP, because when UTP, you will look at the VUTP will look at positive VO saturation. VLTP, you will look at minus VO saturation, yeah. But this VO saturation, you cannot straight away take the value, this value, okay, because there is a Zener diode here, okay, and this V output is after the Zener diode here, yeah. So what you need to do is, you need to consider these two Zener diode, okay. So VBE, which is the forward bias value, okay, 0.7 plus with the Zener diode here, okay, with the value of Zener diode here, which is 5.2. So this will be the output voltage for the positive VO saturations, yeah. So this is going to be the output voltage, which is the 5.9 volts, yeah. And this value you need to put here, yeah, it will be the V reference here, yeah. So replace this, sorry, UTP. So this value will be 5.9 volts, and this value VO saturation, okay, this will be the V reference, yeah, V reference value. Okay, 5.9 volts. VO saturation, straight away take the value of, yeah, why minus 3 here? Minus 3 because of It's given to you. Positive minus saturation is 15, and then 15. Okay, yeah. Oh, because reverse value. Sorry. Okay, because why you need to take this one, yeah, minus 3, because this is the reverse value, which is, oh tak ada kat sini, tapi ada dekat here. Okay, this one, V reverse, patutlah. Okay, so kita tinggal another information here, which is V reference, V reverse, which is minus 3. Okay, so you need to take the reverse value here, minus 3. Okay, because at the reverse value, at the reverse conditions, yeah. So it will be same as well, and you will get 1.45. Okay, 1.45. So for the output, okay, it will be the other way around. Okay, since that it will be minus VO saturation, so minus 5.2 minus 0.7, so it will be minus 5.9. Okay, and then yang ni sama, okay, because this is at the reverse, yeah, it will be minus 4.45. All right, and then what you need to do is so this is going to be the VUTP, and this is going to be VLTP. So yes, okay, so settle for the first questions, yeah, VUTP and then VLTP, right? Next, what you need to do is you need to sketch the waveform. I think after this you need to look back again for these questions, yeah, and look also what is the what is the Zener diode here, yeah. The reverse against Zener diode, because one of the Zener diode here is at the negative side, yeah. This is the reverse side. Okay, so this one is the value is minus 3 volts here. Okay, and the value here will be 5.2 minus 0.7 for this part, yeah. Okay, and then you need to sketch here, and then this is the positive. Tak nampak. This is positive and this is negative. So this will be the UTP, and this will be the LTP based from the what you have calculated just now, and then draw the output. Okay, based from here, draw the output. Okay, as you can see, macam tadi lah. Alright, so here we'll all this information will have 1 mark. Okay, so that's why I give to you this mark scheme as well, so that you know each graph actually how many marks you can get. Okay, at what point how many marks that you will get. Yeah, so that's why it's very important for you to label each point as well. Okay, jangan siapa baru masuk admin. Alright, so this is for exercise 3. Let's move faster. Okay, and then this is for exercise 4. So exercise 4, this is the OP amp. You can see that there has lots of input voltage here. The input is at the inverting, and there is lots of input signal here. And they said here that the input signal is in a binary numbers. It means that it will represent only 0, 1, 0, 1. 0, 1, 0, 1. And 0, it means that corresponds to 0 volts, okay, which means that input signal is 0 volts. And 1 will represent the input signal is positive 5 volts. So D3 to D1, this binary is 0, 1, 0, 1. So it means that at D3, the input signal is 0 volts. At D2, the input signal is positive 5 volts. At D1 is 0 volts, and at D0 is positive 5 volts. Okay, so first of all, what you need to do is you need to determine, since that you need to determine, the question asks for you to determine the output voltage for this circuit. So first of all, for you to determine this output voltage, you need to determine each current flow here first, yeah? So what you need to do is you need to find current, how many currents flow here. Since that this is 0 volts, so it means that the currents also will be 0. So I think for this one, D1 and D2 is very straightforward. There's no current flow from here and here too. So what you need to calculate is you need to calculate DO and D2. Okay, DO and D2. Okay, so DO and D2, okay, since that the binary is 1, okay, and when 1 represents to 5 volts, you will get the value of currents that flow here and here is 0.025 milliamps. Here is 0.1 milliamps. So the total current that will enter here is, you need to plus both together, which is 0.125, yeah, 0.125 milliamps. Okay, so next, you know the total current at this point. So next, you need to look, since that this OP amp here, the positive, the virtual ground is connected to, is grounding, so it means that V positive is 0 volts, yeah. So since that the OP amp always have virtual ground, it means that the value of V positive same with V minus. Since that the V positive is virtual ground, is 0, so the value of V minus also will be 0, okay, will be 0. So in order for you to calculate the V output here, all right, so from the Ohm's law, V equals to IR, so you know the current I, okay, and then V over R here, right? So V is the potential difference. Okay, I will be the value of currents that you calculate just now. Okay, the total current that you calculate just now. V will be the potential difference, which is the output minus the, the input minus with output, yeah? Input minus with output. So input is 0 minus V0 over 10 kilo ohms. And then rearrange this equation and you can find the V output is minus 1.25 volts. All right, so I think for this one, I think this is a straightforward question because there is no any other diodes or any other electronics symbols that you need to consider, only the resistance here. So I think this is very straightforward and this is very easy. The one that you need to quite complicated is for exercise 3. Okay, so please revise again for exercise 3. Okay, up until here, is it okay for the OP amp tutorial?